Hello, thank you. Thank you very much. I'm Jeff Stringer. I'm the CTO at Laika, and I'm here for the after lunch palette cleanser with Jonathan and Martin to tell you a little bit about the work we've been doing at Laika to rebuild our pipeline and how open source has played a big part in that. So Laika is a mid-sized, independent, creatively driven studio in beautiful Portland, Oregon. And we are actually celebrating our 20th anniversary this year. Yeah. And I've been fortunate to have been there for most of that. And Laika, 20 years is the time it takes to make 5 movies, right? They're 5 very memorable, beautiful, ambitious movies, each one a labor of love, but just 5, right? And now, to be fair, we've been in production on this latest film, Wildwood, for quite a long time. It's an ambitious film, for sure. It's an epic tale of magic in a world hidden in a forest just outside of our hometown of Portland, Oregon. And we're trying a lot of new things on this movie. And it's definitely going to change the way we make movies going forward. We've been rebuilding the studio's pipeline while we make this film to try to solve some of the challenges of doing these kinds of movies at scale and to improve the collaboration between our departments. Open source software, especially the projects that are supported by the Academy Software Foundation, have helped make that possible. All of us rely upon open source. It's in the tools that we make. It's in the tools that we make to make the tools. And the work of the foundation that the foundation does to support this community, it gives us, the small independent studios, the confidence to build on these platforms. Well, so why are we rebuilding our pipeline? I mean, we're a stop-motion studio, right? So it should be fairly straightforward after 5 films. And yes, at Laika, we are committed to the art of stop-motion filmmaking. We love it. This is our founder and CEO and the director of Wildwood, Travis Knight. He, in addition to all those things, he's also a very talented animator. And Travis built our studio not only to preserve and maintain this art form, but also to innovate and push the craft forward and expand what's possible, while holding on to the things that make stop-motion magic. And so with each film, we've seen a lot of innovation. Each team is pushing to develop new ways of working to meet creative challenges within their departments. It's a very experimental environment, and there's a lot of freedom to try new things. For example, it was early on in Coraline that we developed the use of 3D printing for facial animation. And with each film, our application of this process has gotten more sophisticated. The volume of faces that we print has really exploded. We're not printing kits of mouths and brows anymore. We're creating thousands of faces as bespoke performances for each character. And this has always been a digital-first process. There's modeling and rigging and animation and texture painting all done digitally, but then the parts are printed and assembled for use on the stage by the animators. The films have also required advances in motion control and robotic rigging systems. We animate every corner of the frame, and we sync with CG elements, and we build rigs to drive creatures that can't be handled easily by animators, like the giant skeleton here. He has a cool moment here at the end of this video. And of course, we've been increasing the integration of CG elements and visual effects, trying to expand the scale of these handmade worlds. And these innovations have all happened organically and within the departments over long periods of time. The processes in each team became more and more customized, and as a result, they became more siloed. So these first 5 films that we did, they were really characterized by these highly innovative departments working in very customized workflows. And ultimately, that limited their ability to share data and work collaboratively. If you've got good eyes, you can see the various artifacts that these departments create, and those things became more and more locked off, where each team had to kind of reinterpret the work of the team before. Not an ideal environment. We like to say that we're pushing the boundaries of stop motion, but on Missing Link, this stuff really came to a head and those boundaries started to push back on us. So we realized that if we were going to continue to scale up our what we did, we needed to build a pipeline around some standards that would allow artists to move easily between the physical and the digital worlds and maintain collaborative continuity. So to fix this, we've been building what we like to call a universal digital pipeline. It connects all the departments from story through production design and fabrication, stage capture and motion control, and then on through our visual effects teams for final integrations. The new pipeline also includes a virtual art department for digital previs at the start of the film so that we create a shared plan for how the shots are going to fit together in the end. And that might seem obvious as a way to approach what are essentially just big visual effects movies, but this has been a big change for us, and not just technically, but also culturally. And the thing that's motivating the willingness of the crew to go through these changes are the creative advantages of the new digital workflows. We can have camera moves that we do in previs that translate directly to the stage. We can bring CG elements out onto the stage for lighting or for animation timing, or for in-camera VFX. And having a parity between assets that are both fabricated and digital is a big goal. So establishing common standards was the way to get that started. Jonathan and Martin are going to share some more details about how open source helped us to find those standards and build these connectors between the workflows. But first, I want to impress upon you all just how significant the changes have been with a couple more fun videos. So this has to do with our puppet making process. Our puppets have always been at the center of our work. These are the movie stars of Laika films and the performance vehicles for the animators. And Laika's puppets are works of art and engineering that have to perform and be handled by animators for a 2-year shooting schedule on a normal film. The process for building these things had remained relatively unchanged for the first 5 films. It was grounded in traditional crafts of casting and molding and sewing and painting, and it takes a long time. On Missing Link, we really struggled with that. The designs of our characters had gotten more and more complex, and the build process was more difficult to predict and plan. If you had some sort of iteration in design, it could set you back months just to go back in this very linear process. Let's let Norman finish his assembly. This is the fun part. Oh, he yawns. Couldn't hear it. But today, we're using Autodesk Inventor to build those armatures. We're using Maya to model the molds and the interior parts. And many of these things can be printed on 3D printers and iterated on in a collaborative sort of process between departments that's nonlinear, so that before we commit to a fabrication, we know what we want. And this has been a huge, huge improvement. And that kind of transformation has been going on in all the departments at Laika. The framework for that had its origins in our visual effects department, which also required a rebuild for the scale of the new project. And Jonathan Gerber has been leading that effort. He and Martin Davies were actually the real champions of open source at Laika. They organized our participation in Dev Days last fall and lobbied for us to join the foundation. And he's here to tell you more about how this happened.
Thank you, Jeff. So this is our vision for Laika's digital pipeline, as Jeff just shared. Developing it is a multi-year endeavor, but I really want to tell a story that begins 4 years ago with 2 departments, Rapid and VFX, our major digital pipelines. Rapid transforms digital facial animation into physical artifacts via 3D printing, one shape at a time. And CFX, you already know, that would typically be a company unto itself. Anyway, 4 years ago, in the midst of a little pandemic, I decided that a change of scenery would be fun, so I packed up my bags and moved to Laika to manage technology for these 2 departments. We had a very small team, 5 TDs, including 2 leads, 2 for Rapid and 3 for VFX. Now, my first reaction was a little bit of concern. That is a pretty small team, but this was Laika. I reasoned, I'd seen their movies, they had things figured out and dialed in already. So Laika is, as you realize, at our core, a stop-motion animation company This is our bread and butter, and I really don't think there's anyone who's better at stop motion. And we've always done beautiful visual effects work as well. Sophisticated, but also intimate. Laika was a company of artisans really working shoulder to shoulder. But now we've begun to gear up for a new show. And the digital footprint was an order of magnitude larger than anything we'd done before. A few thousand digital shots with sweeping, highly detailed environments and a multitude of digital characters, both hero and crowd, and a ton of visual effects. And our VFX department structure in particular was going to have to grow significantly to handle this work, along with our teams. There was no way that we could handle this with our 3 TDs. But here's the thing, we aren't here, or here, or even here. We're here. Technically, we're here. And Portland is not one of the traditional VFX hubs. It's a bit harder to convince folks to move here, and we needed to get going. So how are we going to pull this off? How are we going to punch above our weight? Well, that is where open source comes in. For years, we've all been getting more and more of a lift from the open source community. Gone are the days when you purchased a compiler, libraries, and a bunch of graphics gems books and got going. Open source acts as a huge force multiplier for us. And this is certainly true in the VFX space now, especially with the projects curated by the ASWF. The leg up that we get from the community is awesome. And lastly, for us, we reached for USD, big time. We wrapped everything we could in USD. And here to talk more about that, as well as other details about our integration of open source, is Martin Davies.
Hello, I'm Martin Davies. I'm the lead pipeline technical director on the digital pipeline team at Laika. I hope Jeff and Jonathan has given you a good story of open source and the communities that support it are very impactful and important to Laika. I'm now going to take you on a deeper dive into some of the tools we've developed using these packages. As Jonathan mentioned, the backbone of our pipeline is USD. When we joined Laika, we inherited a setup that relied heavily on USD, but not all parts were given the same or required attention. We set a goal to audit the setup and engage on improving it based on both personal experience and the vast experience of the USD community. The ASWF has been an excellent shepherd of its incubated projects, and the same holds true for USD. With the resources of the USD workgroup and sub-work groups, we embarked on redesigning our asset structure. We have 2 asset structures at Laika. We have one called USD component root and one called USD component asset. USD component root is our legacy asset structure, and it provides the workhorse of the assets on Wildwood. It collects its components into 3 bundles: a model bundle, a rig bundle, and a surface bundle. And they contain contributions from what we call shops, which traditionally in other VFX studios would be considered departments. Unfortunately, with component root, these bundles contain more than just what they say on the tin. For instance, our model bundle contains geometric variants, UVs, grooms, USD preview surface, and an auto rig. So it's doing a lot more than it says. We had the requirement to meet these large-scale shots on Wildwood, and one thing we had to do to limit was LOD support. We did not support LODs in component root. USD component asset came along using the asset workgroup's guidelines to primarily provide that support, as well as some extra things whilst we were in there, like class prim support, nested variant sets, and USD shade. Our shot structure is a little bit different compared to what you may have seen at other studios. Where some other studios may contribute a layer per shop, ours takes a different approach. We have something called a shop bundle, and if you don't realize by now, we like to bundle things. And each asset contribution in the shop bundle is something we call an instance bundle, more bundles. Our structure begins with some layer metadata at the top. This helps us with our digital asset management. It holds stuff that we can easily query from a USD file and look up in our asset management system. Next, we have our sublayers for our instance bundles. These are pointing directly to another asset in our asset management system. We call them deliverables, and actively sublayers the instance bundles in. And then we have some initial shot prim hierarchy for those sublayers to override. What's good about this is we can avoid race conditions. If two artists are working on the same scene, they can contribute to direct instance bundles as opposed to one layer for their department. What's bad about this is we end up with a lot of complexity, and stuff like muting layers per shop would require us to go through every single instance bundle and mute them at that level. So USD. Is it really universal? The answer is yes. And I'd like to talk about universality at Laika. I'm going to dive through some tools that we've built using USD and some other open source software and describe it. We have something called Scene Machine. Scene Machine is a single API that allows TDs to interact with our asset management system and to integrate, directly manipulate USD to build a scene for rendering. We have been able to use this universally as opposed to a single bespoke QC renderer per shop or workflow. So here are some things that Scene Machine has helped us to create. We have a turntable of some Douglas firs from Wildwood, and a scouting shot for environment layout. As well as allowing you to pull from the asset management system and directly manipulate USD, Scene Machine provides an interface for TDs to define a render platform. This pulls away the complexities and requirements for deep renderer knowledge, and TDs can directly render from their tools. We're quite far in the production of Wildwood. We've locked down to Maya 2023. There are some implementation of USD capabilities that are not available, being so far back. To access a larger set of USD features, we developed the Laika USD outliner for Maya. This is USD View Lite. It provides a prim hierarchy, access to properties, access to variant sets, and access to layers with the ability to mute and see some of our asset management data in one interface. Our previz department, as Jeff mentioned, is relatively new. They work in Unreal. USD has powered us to be able to publish various amount of products from Unreal into our asset management system. I'm going to talk about two here. We have a camera publisher and a level publisher. These interact directly in Unreal and produce USD into our asset management system that, if you have good eyes, you'll be able to see is in our interface into the asset management system DAM browser. This is one from the camera publisher. and one from the Level publisher. When these products are published, our asset management system is powerful, and the VFX department knows there is something new to pick up automatically. So USD gives us a bit more as well. We have many DCCs, many shops have different tool sets. USD helps us be the glue between that. And Dan Browser has a plugin system that lets us build generic actions to work on our products. Here is an action in Dan Browser where we are loading USD View. USD View loads with our payloads unloaded by default, but turning them on, we can see the tree. Here is Dan Browser with an action to load USD Explorer. USD Explorer is an in-house wrapper UI for USD Cat, and we took the text highlighting from USD Manager that was open sourced by DreamWorks Animation. The actions are very powerful. It allows us to push assets across shops and DCCs. This action is our reference action. It allows us to reference in USD files onto the active edit target. In this example, I've run the reference action and loaded in a tree into Maya. But this is also available via Dan Browser in Houdini, Katana, Blender, and Nuke. We learned pretty quickly that deliveries to Compositum were not efficient. We had each AOV was published as a separate EXR. Nuke would get bogged down, consuming huge quantities of images that we needed for some of these shots on Wildwood. We investigated using multi-part EXRs and used each of these packages to help us achieve that. I don't know if you guys can see that, but the best I could show for an image from Wildwood is the output of OOI tool. Right at the top, you can see we have 11 sub-images here, and it's a great progress for us to help the load on Nuke. We also used OpenImage.io and OpenColor.io to build various libraries that are accessed by many departments around the studio. Here you can see a contact sheet that was generated from a package that's very important to us called Laika contact sheet. It consumes a multi-part EXR and generates a contact sheet from them, like the image you see here. This is actually a pretty interesting image, although it's kind of boring on screen. It's a turnover contact sheet from the stages. They use the same software we have developed in Digital Pipeline to create these contact sheets and to push turnovers to digital departments. This has allowed us to move away from supporting packages like ImageMagick or consuming costly third-party software licenses. I hope you enjoyed our glimpse into some of the tools. Thank you for listening. We're very excited to be part of the ASWF as a member, and I hope you all have a good SIGGRAPH and open source days.